Hello students, welcome to ACE Engineering Academy and ACE Online. Myself Ramesh Masuna. Here we are going to discuss the memory based questions for GATE Computer Science Engineering afternoon shift. And as we got some of the questions from our students, and those are memory based questions, it is purely based on the questions received from the students. We are giving answers for the questions. It may not be exactly the questions what occurred in the GATE examination. It is based on the questions that we have received from the students. First, I'll talk about database management systems. As I heard that from DBMS we got 6 questions, that is 4 plus 2, totally of 8 marks came from DBMS. In that, so far I have received only one question, that is question from normal forms. The question is something like this. The question is, which of the following relation is in third normal form? And here given two relations, relation 1 with A, B, C, D, E with functional dependencies given, relation 2 with A, B, C, D, E with functional dependencies are given, and options are given only R1, only R2, and both R1 and R2, and option D given neither R1 nor R2, neither R1 nor R2. Here we have to see which option is correct, and now we'll see what is the normal form of R1 and R2. R1 having these dependencies, so find the key for R1. Now what is the key for R1? Just look at what are the dependent attributes C, B, E. So independent attributes are A and D. So AD is possible to become a key for the relation. Now just check it, is it AD is a key or not by finding the closure of AD. That AD closure is A, D, E, because with D we are getting E, with EA we are getting B, with EB we are getting C, all attributes. Now AD is a key. If AD is a key, A and D are called prime attributes and remaining attributes are non-prime attributes. What are the non-prime attributes? B, C, D. Here you observe one dependency D to E where D is a prime attribute and here E also there, right? E is a non-prime attribute. Okay, instead of D, E is a non-prime attribute. D is a prime attribute, E is a non-prime attribute. This is a prime attribute to non-prime attribute relation that is called partial functional dependency. If a relation do have partial functional dependencies, we can call the relation is in the first normal form. But the question is asking about which relation is in 3NF. R1 is not in 3NF, R1 is in 1NF. So both is incorrect, A is incorrect. Now we have to look for R2. In R2, the relation is given A, B, C, D, and these are the dependencies given. For R2, we find the key for this. Now what is the key for R2? Look at A, B, D are the dependents. Now what is independent? C, and C is possible to become a key. What is the closure of C? C, A, B, D, all the attributes. C is key. When C is a key, prime attribute is C, and non-prime attributes. What are the non-prime attributes? A, B, and D are the non-prime attributes. And here you look at, it is a non-prime to non-prime relationship. Non-prime to non-prime relationship is called transitive dependencies. If the relation do have transitive dependencies, relation is in which normal form? Second normal form. It is also not in the third normal form. It is a meaning that option B is also wrong. Then we can say option D is the correct answer because neither R1 in 3NF nor R2 in 3NF. So answer for this question is option D. And coming to the compilers, I have received some information that there is totally 5 questions came and there is a total of 8 marks from compilers. And in that 5 questions, I have received only one question, that is from LR parsers. And the great thing is the question, I don't know what exactly it is correct. This is a question is given from our students and have seen from the students community, and this is the same question which is exactly appeared in our classroom practice question booklet. Look at this question. And this classroom practice question booklet is there from past 10 years. In the past 10 years, we'll be solving the same question. Look at this is a question number 61 in our classroom practice booklet. So this is a question, and the same question appeared in the GATE exam. So that's definitely great thing about ACE Academy. Say, look at, this is a question given, the grammar given, and asked about the grammar is SLR of 1, LALR of 1, LL of 1, and LR of 0. Testing LL of 1 is simple. It should not have any common prefixes. Look for that. Here we have a common prefixes for these two productions. Because it is having common prefixes, it is not LL of 1. Next we have to look for LR of 0, SLR of 1, and LALR of 1. For this, we have to find the states. Starting with S dash tends to dot S, S production is dot capital A small a, and dot BAC, and S tends to dot DC, S tends to dot BDA. Because dot A is there, we add A production also with the dot D. We don't have any conflict here. When you move dot one position to the right with respect to S, we will get state with one item that never causes any conflict. With capital A also one item. With small b, we can have multiple items. S tends to B dot capital A small c, and because dot B we have two possibilities, and B dot DA both will appear in the same set, and dot capital A is there. Capital A means we have to write A production, that is A tends to dot D. And here we don't have any conflicts, and with look at with respect to D, we have two possibilities. S tends to D dot C and A tends to D dot, and clearly it is a shift reduce conflict in LR0, right? Because it is a shift with respect to C and this is a reduction. So LR of 0 is wrong. Next we have to look for SLR of 1. In SLR of 1, this is a shift reduce conflict if the shift symbol C, and this is a reduction in fall of A. Now what is the fall of A? Look at what is the fall of A, C and A. A and C are in the follow set. It means these two will have a common symbol C. It means in the state I on input C, we have to write one shift action with respect to C, and A tends to D is reduced. This is shift as well as reduced. So because it is shift reduce conflict in SLR of 1 also, so that SLR of 1 is also wrong. Then we have, means because three options are eliminated, finally we can say LALR of 1. So answer for this question is LALR of 1. If you want to check, you can add up the lookaheids. So here we have a look at dollar, and for this all the S productions, lookahead is dollar, lookahead is dollar, and for this A production, lookahead is A. Okay, I'll write with some other color. For all these, we have a look at dollar, 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 and this lookahead is A. And you look at when dot moves with respect to right, it is a dollar, and here with respect to dot, here the lookahead is A. It means this is going to be have shift action on input C. This is a reduction on A. In LALR of 1, in ith state on input C, we have a shift, and this reduction of A tends to D should happen in the lookhead, that is A. In the lookhead, we have to perform a reduction. This is not a conflict in LALR of 1, so the grammar is LALR of 1. Okay, this is the only question we have received so far on compilers. If more questions come, we'll come back again for DBMS and compilers question. And my friend is going to continue with the session. Thank you.
myself P. Venkatrao, mathematics faculty. So we received 3 questions from students. Question number 1, if L and M are two non-singular matrices of the same order, they said L and M are two non-singular matrices of the same order such that L square equal to L inverse, M equal to L to the power of 8 and N equal to L square. They said L and M are two non-singular matrices of the same order such that these conditions are satisfied, and we were asked to find determinant of M minus N. So first of all, if L square equal to L inverse, then L cube should be L into L inverse I. We were asked to find determinant of M minus N. So first let us find what is M minus N. M minus N is L power 8 minus L square. L power 8 I can write L cube L square minus L square. As you all know, L cube is identity matrix. So L cube is I into I. So therefore it is L square minus L square 0. So therefore M minus N is 0. So accordingly determinant of, we were asked to find determinant of M minus N. So determinant of M minus N is 0. Next question. Suppose A equal to 1 to 2 minus 1. Find A to the power of 8. So we were given A and we were asked to find A to the power of 8 regarding in terms of the matrix only. So if I write the characteristic equation from this, you will get the characteristic equation as lambda square. Lambda square minus 5 equal to 0. By Cayley-Hamilton theorem, every square matrix satisfies its own characteristic equation so that A square minus 5i equal to 0. So from this A square equal to 5i, and we were asked to find A to the power of 8. That means A square whole power 4 equal to 5i whole to the power of 4. A square whole to the power of 4, that is A power 4, 5 power 4, that is 625, I power 4 is identity matrix. So therefore 625 0 0 625. Actually we were given 4 options. All options are given in terms of 5 0 0 5 625 0 0, something like that we were given. So this is the answer. And one more question we received from students from calculus regarding definite integrals, and it is like this. If integral 1 to x t ln t dt equal to 1 by 4, then the value of x is. So from this just apply Eilert rule. Ln t into integral t dt between the limits 1 to x minus integral 1 to x ln t integration 1 by t into integral t dt. Eilert rule I am applying, whole dt equal to 1 by 4. Now replace integral t dt, that is t square by 2 into ln t between the limits 1 to 2 minus integral 1 to x into integral t dt, that is t square by 2, t square by 2t, t square by 2t, that is t by t dt equal to 1 by 4. So replace t by upper limit 2, 2 square 4, 4 by 2, 2 ln 2, sorry, this is upper limit is x, no? Then it is x square by 2 ln x minus replace t by lower limit 1 ln 1 0 minus integral t dt, that is t square by 4 between the limits 1 to x, that is equal to 1 by 4. So x square by 2 ln x square by 2 ln x minus replace t by upper limit x square by 4 minus replace t by lower limit 1 minus 1 square by 4 equal to 1 by 4. So from this x square by 2 into ln x minus x square by 4, here minus into minus plus 1 by 4, that 1 by 4 cancel, so right side 0. So therefore from this x square by 2 common, if I take x square by 2 common, then it is ln x minus 1 by 2. If I take x square by 2 common, so x cannot be 0 because integration ranging from 1 to x, so that's why x cannot be 0. So ln x minus 1 by 2 equal to 0. So from this ln x equal to 1 by 2. So this is natural logarithm ln x to the base e. So from this x equal to e to the power of 1 by 2. means x equal to root e. These are only the questions I have received from students community. Further, if you receive any questions later, we will update you. Thank you. Next, my colleague will continue. Thank you.
So now we are going to have a discussion about the CN questions as well as OS questions. As per the collected data from the students, we got 4 questions from computer networks as well as 2 questions from operating system. And the difficulty index of these 2 subjects is easy, except that multi-level paging question, and remaining all questions are easy. So coming to this question, it is a straightforward question which is based on routing algorithms. So there is a link state routing algorithm is there and distance vector routing algorithm is there, and link state routing algorithm and distance vector routing algorithm needs to be compared with Bellman-Ford algorithm as well as Dijkstra's algorithm. So option A, it is given LSR is using Bellman-Ford, option B, it is given LSR is using Dijkstra, option C, it is given distance vector is using Bellman-Ford, and option D, distance vector is using Dijkstra. So if we can check here, the point is here link state routing algorithm, you know that it is building shortest path tree before constructing the final routing table. So before constructing the final routing table, it is constructing the shortest path tree using Dijkstra's algorithm, but not based on Bellman-Ford routing algorithm. So that this is the correct matching here. So this particular one is correct matching, which is link state routing and Dijkstra's algorithm is the correct matching. Then coming to distance vector routing, you know that distance vector routing algorithm is implemented by Bellman-Ford. It is introduced by Bellman-Ford and implemented by Ford-Fulkerson. So that distance vector routing algorithm is also called as Bellman-Ford routing algorithm, means your distance vector routing algorithm is using that Bellman-Ford principle. So that is why distance vector routing and Bellman-Ford both are correct matching. So that the answer for this question is B and C. So mind this one more time, I am clearly insisting that these are the data that we have received from the students, and purely they are memory based but not exact. Okay, whatever the data that we have covered, collected from the students, based on that data only we are providing the solutions and the keys here. When the original paper is being released, then again we will come back in front of you with exact question statements with the exact solutions as well as appropriate keys. But these are just memory based, mind this, okay? Right, so let us move to the next question. Yeah, so here, this is the question from IPv4 datagram header format. So coming to this, IPv4 packet has X written in its protocol field. The protocol X can't be. So you know that as part of IPv4 datagram header format, you have protocol field, right? So what is the size of this protocol field? It is the size of 8 bits, right? So, and we clearly mentioned that what this protocol field defines, this protocol field defines the upper layer protocol's data or else the same layer's protocol data which is been carrying by IP protocol, right? So which means that if it is ICMP is part of, it can be encapsulated into IP. IGMP also encapsulated into IP. So I believe if the protocol field value is 1, then it is ICMP. If the protocol field value is 2, then it is IGMP. And I clearly mentioned OSPF is a reliable, it is a reliable multicast protocol. It is a reliable multicast protocol. It means it is not using any transport layer as a transport protocol. It is not encapsulating into TCP as well as it is not encapsulating into UDP. It is encapsulating directly into IP. Okay, but when it comes to the RIP is encapsulating into UDP, but not IP, right? So RIP is encapsulating into UDP, and this UDP is encapsulating into IP. But RIP is not directly encapsulating into IP. But IGMP, ICMP, and OSPF, these are encapsulating into IP. Hence, the protocol X can't be is what? The RIP. RIP is not part of, not encapsulating into IP. Hence, the answer for this question is option C, right? So let's move to the next question. Yeah, so this is again based on IP fragmentation. So here you have UDP payload. The question is mentioned it is UDP payload. It means here you have transport layer. At this transport layer I have UDP datagram. This UDP datagram, as it is mentioned payload, as we have received the information as payload here. Payload means data field. Data field is what? 7488. Okay, and you know that UDP header is what? 8 bytes. And when it comes to the network layer, this is getting encapsulating into IP. So now this is IP header which is 20 bytes, and total this is coming into data portion of your IP. So what is that? 7496. So now this particular 7496 we need to fragment here. So 7496, which means this packet we need to be forwarded via this interface. So this interface is having MTU of what? Ethernet interface. What is that Ethernet interface? 1500 bytes. And you know that it is by default divided into 1480 and 20. Which means that this 7496, always it can be forwarded from this end to this end only 1480. Which means the number of fragments, how we can calculate? So the number of fragments is equals to, 7496 divided by 1480. So if you consider this, you are going to get something like 5.06 or something, which is totally you are getting 6 fragments here. So 6 fragments is the answer for the first question, number of fragments. Then the size of the last fragment. So size of the last fragment in the sense, out of, this is 5.06, which means the first 5 fragments, the first 5 fragments are having 1480, 1480, 1480, 1480 and 1480. These are the full fragments, and the leftover portion is part of your IP fragment, last fragment. So this last fragment is going to have, by adding all of them, whatever the remaining is there, that is going to be part of this, plus you have to add the 20 bytes of header. This could be the last fragment size. Okay, this could be the last fragment size. 20 bytes of header plus the data portion. After this is totally 1480 into 5. That can be subtracted from 7496, and leftover is going to be your data portion plus this 20 bytes is the answer for this size of the last fragment. Okay, right. Let's move to the next question. So this is a simple question again from stop and wait protocol. Here the question is clearly mentioned. Packet size is given 3000 bits. Bandwidth is given 2 kbps. From these two you can calculate Tx is equals to L by B. L is 3000 by 2 kbps, which you can write as 2 into 10 power 8. So what is this? 1500 milliseconds, correct? This is 1500 milliseconds. So TP is 100 milliseconds. This is TP, propagation time, okay? So then from these two what you can calculate? A is equals to TP by Tx. What is the TP? 100 by Tx, 1500. So which is 1 by 15. So what is that 1 by 15? If you can evaluate, 1 by 15, if you can evaluate, you are getting something like 0.06. I hope so it is 0.06, right? 1 by 15 Yeah, so 0.06. This is A value. And this is stop and wait protocol. You know that stop and wait protocol efficiency is what? 1 by 1 plus 2 into A. So 1 by 1 plus 2 into 0.06. So 0.06 into 2, which you are getting 0.12, right? Then it is 1 by 1.12, right? So then 1 divided by 1.12, you are getting, see, 1 by 1 plus 2a. So by evaluating this expression, if you can see that this particular expression, by evaluating this whole expression, at last I am writing the answer here. By evaluating this whole expression, you are going to get something like 88.23 you are getting. 88.23 you are getting. 23 or 26 something you are getting. Okay. So this is what the efficiency answer for this question. Right. So these are the 4 questions we have from CN. So then we are coming to OS. So here this is what the given question, I mean this is what the given data and we are applying SRTF and it is asking us to calculate the average turnaround time. Okay. So first if we can build the Gantt chart for this question. At 0, you have only P1 process with 10 burst time. So since it is the only one process, we can hand over it to the CPU. It is allowed to get executed up to 1, the next arrival. What is the next arrival? 1. So by that time, P1 is running with 9 and P2 is coming, P2 is arrived with 13. So this is what your newly errored process. This is currently running process. The newly errored process burst time is higher than the currently running process. So that no preemption means P1 will be continued up to what? Up to the next arrival. What is the next arrival? 2, right? So by this movement, P1 is running with 8 remaining burst time, P2 is there with 13, and P3 is arrived at 2 with 6 burst time. So now the newly errored process burst time 6, currently running process is 8, means preemption can be taken place, means P3 will hand over, and it is going to be executed till 8. So by 8, what is the status? P1 is there with 8 remaining burst time, P2 is there with 13 remaining burst time, right? And by 8, who is coming? P4 is coming. P4 is coming with 9 burst time. Then which process is going to start its execution? P1 is going to start its execution up to 16. By 16, you have P2 with 13, P4 with 9. So among these, which process is going to be executed? P4. So P4 is going to get executed till 25. So by 25, you have only P2 with 13, so that P2 will hand over and it gets executed till 38. So this is what the Gantt chart here. Then completion time if you calculate, so P1 is finished by 16, P2 is finished by 38, P3 is finished by 8, and P4 is finished by 25. Then turnaround time, if it is asking turnaround time, 16 minus 0, 16, 38 minus 1, 37, and 6 minus 2, 4, 25 minus 8, which is 17. So this is 16, 17, 33, 33 plus, what is this? I mean, this is 6, right? 8 minus 2, 6, yeah. So 33, 37, 76, right? So 76 by 4, which you are getting 19. So 19 is the answer for this question. So this is 6. 8 minus 2, 6, right? So 19 is the answer. Average turnaround time is 19, right? So next, there is one more question we have from multi-level paging, which is based on 2-level paging. So logical address is 32 bits, page size is 4096 bytes, and entry size is 8 bytes. Okay, so you know that this is what your CPU, this CPU is generating the logical address, which is 32-bit length. And this is being divided into 2 parts. One is P, another one is D. What is the D? This is 2 power 12, right? So that offset is, this you can write as 2 power 12. Yes or no, 2 power 12 bytes. This is 12 bits, 12 bits is offset and remaining 20 bits is your page number, but this is mentioned a 2-level paging. So which means that this particular one is being divided into P1, P2 and D. D value is anyway 12, right? So then what we have to calculate here first, the number of entries in one page, the number of entries in one page of inner level page table is equals to page size by entry size. What is the page size? 2 power 12 divided by what is the entry size? 8, which is 2 power 3 bytes, which is you are getting 2 power 9. So it means that the number of entries in one page of your inner level page table is 9, means your P2 value is going to be 9. So out of 32, if 12 bits are here and 9 bits are here, then your outer level page table, number of bits to search in outer level page table is what? 11. 12 plus 9, right, 21, 21 plus 11, 32, right. So this is the way how we were two level logical address space is being divided, which means 2 power 11 entries are part of your outer level page table, and each entry further contains 2 power 9 entries, and each entry of this inner level page table contains 2 power 12 bytes of data. This is the way how your logical address is being divided, which is 2 power 32 bytes of logical address space is being divided. So the question is asking about number of bits to search in outer level page table, that is 11. So whatever the solutions and whatever the keys that I have given here, these are purely based on memory based data only, okay. So once the question paper is being released, you will get the exact answers, right. Thank you so much, and next my colleague is going to continue with the next subject.
Welcome to all. This is Wavecont, COA faculty. We are going to discuss the questions. What I have received from our younger friends means these are purely memory based questions. I have received this from reliable sources, that is nothing but our GATE aspirants, and I came to know 5 questions from our subject. Actually, I didn't have 100% clarity in this. That's why the information what I have received means what I am having 100% clarity in the information. We are going to make discussion here. In this, one question from pipeline. It is easiest question. Next, second question on 3-level memory hierarchy. It is also easiest question. Next, third question on processor means CPU architecture. Basic knowledge means general knowledge is enough to solve this question. Next, one more question on direct map cache. Direct map cache memory. Next, Booth's algorithm. truly speaking, I don't have 100% clarity from Booth's algorithm question because I have received this question from only one student. That's why it can be correct or not, I don't know. Actually, after releasing the official paper from the IIT, we are going to make session for discussing the same questions once again. So these are purely memory based questions. Come to first question. In this pipeline question, according to given information, number of stages in pipeline is 5. K means number of stages. At the same time, stage delays are given like this: 150 nanosecond, 250 nanosecond, 100 nanosecond, 200 nanosecond, and 250 nanosecond. 5 stage delays are given like this. Along with this, buffer register delay is also given. Buffer register delay 10 nanosecond, and he mentioned the number of instructions to be executed, nothing but 1000. Then he asked the total amount of time needed to execute this program on pipeline processor in microsecond. It is NAT question. He asked the total amount of time needed to complete this program execution on pipeline processor. Nothing but, already we know it is simple and easiest question, k plus n minus 1 into T segment. In our style, what is T segment here? 1 segment delay time. How to compute this? First find the longest delay consumed by the one of the segments, nothing but 250, plus buffer register delay. Buffer register is also known as latch, nothing but 260 nanosecond. Here k plus n minus 1, nothing but 1004. Here compute the value, convert the same thing into microsecond. Okay. Next, come to next one. Second question. This question has some trick. It is nothing but tricky question. Watch this. He mentioned the direct map. Type of mapping is direct. At the same time, he mentioned the tag bits in physical address format. Tag size in physical address format. How many? 4 bits. Means each cache line requires 4 tag bits. Index size is 12 bits. Next, each block size is 1 byte. Watch this one. Each block size is 1 byte. It is tricky question because of this information. Because of this information, it is tricky question. Now, what he asked, size of main memory and cache memory respectively. He asked like this. At the same time, it is MCQ question. These are purely memory based questions. Options are like this. A, 64 KB, capital B means bytes. Next, 4 KB. Option B, 64 KB, 8 KB. Option C, 128 KB, 4 KB. Option D, 128 KB, 8 KB. Watch this. In this, each block size is 1 byte. to select one of the 1 byte. No address is needed. We know the physical address format in direct mapped cache. Nothing but physical address, nothing but a tag. Leftmost field is known as tag. Middle field is nothing but index, also known as cache line number, nothing but byte address or byte number. In this, how many bytes are there? Only 1 byte. To select one of the 1 byte, not needed to discuss the address field, that's why it is 0. Now, according to information given, this size is 12 bit and this size is 4 bit. So what is PA size? 16 bit. With 16 bit, maximum number of bytes to be addressed is 2 power 16, means main memory size is 64. 2 power 16 bytes means 64 KB. At the same time, middle field and last field tells the size of the cache memory. Then cache memory size is 12, means address size is 12 bit, means 2 power 12 bytes, means 4 kilobyte. Hence, correct option is option A, 64 KB, 4 KB. Has got the size of main memory and cache memory respectively. Come to next question. In this question, truly speaking, regarding this question also, I have not received 100% clarity regarding the information. That's why I am going to discuss the basic information on this question. Which one includes the instruction set architecture? Architecture in the following. It is nothing but MCQ. Come to options. Option A, number of CPU registers, REGS means registers. Option B, size of CM cache memory. Option C, number of cache levels. Option D, size of main memory. Here, instruction set architecture, it includes only number of processing registers fabricated in the processor. So, if given question is like this, correct answer is A only. Okay. Next, come to next question. This question on 3-level memory hierarchy. According to information what I have received from the reliable sources, he mentioned the levelings means in serial connection, and 100% clear information is not yet received. That's why what he mentioned here, T1, H1, T2, H2, T3. H3 is not needed to provide because H3 means hit rate of last level memory, nothing but 100%. So average memory access time, he asked the average memory access time. Already we know the expression. H1 T1 plus H1 into T1 plus 1 minus H1 means miss rate in level 1 into H2 hit rate provided by level 2 into T2 plus T1 because it is nothing but serial connection plus 1 minus H1 miss rate in level 1, 1 minus H2 miss rate in level 2 into T3 plus T2 plus T1. If you substitute these values here, we get the answer. Next, one more question. One more question is there from Booth's algorithm, but I have received that question from only one student. That's why I'm not interested to discuss that one. Okay, thank you. And our colleague will follow the same.
Yes, dear friends, now this is the digital logic. Logic gates, very simple question from the OR gate, NAND gates, NOT gate. Now what is the question? Observe here. What is the value F in the circuit here? Simple, it is a observe. Now coming to the this Y bar X, XY complement. Now is Y connected, Y complement. Now here observe, this is a Y bar, Y complement and X, XY complement. Now what is the value of F is asking. The question is XY complement plus Y complement plus XY complement here. Now according to De Morgan's law, XY whole bar equal to, come on help me, tell me, X bar plus Y complement plus Y complement plus XY complement here. Now here Y complement, A plus A equal to A only. So Y complement equal to Y complement only, X complement plus Y complement plus XY complement. From this two, take the Y complement is common, X bar plus Y complement, 1 plus X. 1 plus something is 1 only. So what is the correct answer is X bar plus Y bar, or we can also write XY whole complement. Both are correct answers only. If the options is given X bar plus Y bar also correct, XY whole complement also correct, there is a question from the logic gates here. Now one more question from the digital logic here. Yes. The 4-bit triple counter time period of the waveform of the last flip-flop. FF means flip-flop here. Flip-flop, last flip-flop is 64 microseconds. So last flip-flop is given. What is the question now? Observe. Now, what is the input clock frequency of ripple counter in kilohertz? These questions are memory-based question, whatever we received from the students only. Now, memory-based question. Yes, ripple kilohertz here, this is a, okay, fine. Already in the classroom, we were nicely discussing about the ripple counter, asynchronous counter. In the question paper is given 4-bit ripple counter, but in the classroom, observe 3-bit ripple counter we were discussing here. This is the question, observe 3-bit ripple counter here. Okay, this is a 3-bit ripple counter, but question is 4-bit ripple counter. What is the ripple counter here? Asynchronous ripple counter, LSB bit, this is a LSB bit here, LSB bit. Direct input clock frequency is LSB bit. Next, okay, Q2. The frequency at first one, is equal to Fi upon 2 power 1. At second one, input Fi upon 2 power 2. At last one, frequency equal to last one, the frequency equal to Fin upon Fi by 2 power 3. Now at last 4-bit means 2 power last frequency. Okay, clock frequency equal to what is given. Now, okay, fine. At fourth, I have taken 3 in the classroom, but in the fourth flip-flop, at fourth one, the input frequency by Fn by 2 power 4. So Fn by 16 here, Fn by 16. This is a frequency. What is the time equal to? Time period equal to, okay, this is a frequency, Fn by 16 at the last one. But in the question paper is given what is the input clock frequency here. Now time period is given. Already we know frequency equal to reciprocal of the time period. Wow, good. Frequency equal to reciprocal of the time period. What is the time period is given? 1 upon 64 microsecond. Microsecond means 10 power minus 6 here. This is given. At the last flip-flop is given. At the last flip-flop from the previous question, f in by 16 here. So 1 upon, now, okay, fine. F in by 16 equal to, f in by 16 equal to, tell me 1 by 64 into 10 power 6 in the numerator 10 power 6 only. 10 power 6 only. So 16 cancel here by 4. So f input equal to, clock input frequency equal to, this 10 power 6 equal to, we can write 10 power 3 product of 10 power 3 upon 4 here. 10 power 3 is nothing but 1000. 1000 by 4 equal to 250. 1000 by 4 equal to 250. This 10 power 3 is nothing but kilohertz. In the question paper, read here clearly, kilohertz here. Be careful here, kilohertz here. So kilohertz means 10 power 3 is nothing but kilohertz. So in the question paper already kilo is given. So answer is in hertz equal to, perfect answer is 250 is correct answer. These are the questions from the digital logic.
Hello everyone. Now I am taking this opportunity for explaining questions from programming in C. Actually, we didn't get complete information about programming in C questions. So let me discuss one or two questions, friends. Okay, this is the afternoon session questions. See, there is an array having 3 elements 30, 50, 10, and also they define a pointer PTR which is assigned with ampersand of a of 0 plus 1, means address of 0, address of a of 0 plus 1. Afterwards, a equals to star PTR, next star PTR plus plus, and PTR equal PTR plus 1. And finally, they are asking printf percentage d a plus ARR of 1 plus star PTR. Kindly verify whether this is a reliable question or not, okay? Because some students have sent this question, that's why I am discussing the class now, just observe, friends. So first I created an array where ARR is a array name always holding base address of the array. Here base address of the array is 100, that's why I stored into ARR. Afterwards, here PTR is a pointer pointing of type integer, that's why I created PTR, right friends, okay? Afterwards, take address of 0th element, take address of 0th element. So what is the address of 0th element here? We can say it is ARR of 0, ARR of 1, ARR of 2, right friends, okay? Therefore, address of 0th element that equals to 100, 100. So hence this statement we can write like this, okay? PTR is equals to address of a of 0. So address of a of 0 means that equals to 100. So it is taking 100 plus 1. You all are aware about this kind of addition. It is not normal arithmetic addition. In normal arithmetic addition, we can write it is 101. But it is a scalar is adding to the pointer, right? Therefore, it should be multiplied by the size of the data which is there pointing. Clearly, this pointer is pointing to integer data. That's why it is multiplied by size of the data. I am assuming that the size of integer is equals to 2 bytes here. Therefore, I have to multiply with size of integer like this. Okay. So whenever we are adding scalar to the address, that scalar must be multiplied by the size of the data which is residing in this address. Therefore, 100 plus 1, 2 that equals to 102. So PTR is holding value equals to 102. Hence, it is pointing to 102 location. The moment it is pointing to 102 location, we can access this content by using star PTR, right? So therefore, star PTR is nothing but 50. That 50 copied into variable a. So a is equals to 50. After star PTR plus plus, okay. So where is star PTR? So star PTR means go to memory location of star PTR. So this is a star PTR. So plus plus means you need to update its value to 1. That is 50 plus 1 that equal to 51, okay. Because you are moving to that location, you are updating that content, 50 becomes 51. Now afterwards PTR plus 1. What is the content of PTR? 102. Therefore, this statement's meaning is PTR is equals to, take content of PTR. So content of PTR equals to 102 plus 1 into size of pointer, size of the data. The size of the data is equals to 2 bytes here. Therefore, it is multiplied by 2. Because whenever we are adding scalar, that scalar should be multiplied by the size of the data which is residing in this address. Therefore, 1 into 2 which is equals to 104. Therefore, PTR is updated to 104 location. So PTR is equals to 104. Hence, this link got modified and it is pointing to 104 location. And we can access value by using star PTR now, right? Star PTR. So therefore, you can take a. A means variable value that equals to 50. Just look at a is equal to 50 plus ARR of 1. So what is ARR of 1, friends? That equals to 51. So ARR of 1 equal to 51 and star PTR. So star PTR is equals to, we are having 10. So we are taking value equal to 10. So 50 plus 51 plus 10 that equals to 111 is the correct answer. So this is one question came from the pointers. Very easy question, friends, okay. And I heard that there is one question based on like GCD, greatest common divisor question, okay. But I don't know whether it is reliable question or not, just verify. So this is a question asked in the gate paper. Please verify whether it is really correct or not. They provide x is equals to 126 and y is equal to 105. If x greater than y, x equal to x minus y, otherwise y equal to y minus x. And this condition you have to do as long as while x not equal to y, afterwards you have to print the value of x. Okay. So this is GCD based questions, verify if the question is correct or not. If it is correct, the explanation is looking like this. x is having value equals to 126 and y is having value equals to 105. First check the condition x greater than y, okay, x greater than y. Obviously 126 is greater than 105, condition true. So if this condition true, we need to update x value, friends, x value. So x value becomes 126 minus 105, okay, 126 minus 105, you will get approximately it is 21, right, 21. So therefore x value is updated to 21. Afterwards again, while x not equal to y, so clearly x value not equal to y, condition satisfied. So therefore if x not equal to y, again you have to repeat this condition, do while loop. Now check the condition x greater than y, x value is 21, y value is 105, so this condition fail. Then else part will be executed, y will be updated now, y equal to y minus x. So y value is equal to 105 and x value equal to 21, so we will get result equals to 84. So y is updated to 84, okay. After updating, again check the condition x not equal to y, so clearly 21 not equals to 84. Therefore check the condition x greater than y, so x value equal to 21, y value equal to 84, so x greater than y condition fail. Therefore else part will be executed, else equal to y minus x. So what is the value of y? Y is equal to 84, x value is 21, the result is equals to 63, right. So y is updated to 63, right friends, okay. Now check the condition while x not equal to y, yes, x not equal to y condition satisfied. Then again check the condition x greater than y, so 21 greater than 63, condition false. Then y is updated, y equal to y minus x. So 63 minus 21, that equals to 42. So y value is updated to 42. After checking this condition, again condition fail, else part will be executed, y equal to y minus x, that is 42 minus 21, that equals to 21, right. So y value becomes 21. Once y value equal to 21, this condition fail, while x not equal to y condition fail, print x. So what is the value of x now? That equals to 21. So these are two questions came from programming languages. Of course there are many questions also there, but we don't have any reliable source, that's why I am not discussing these questions, friends, okay. Similarly I came to know that from algorithm subject, okay, they are asking question, what is the time complexity for finding an element which is not largest, from the array of n elements. Obviously if you want to find an element which is not largest from the array of an element, simply compare a of 0 and a of 1. Suppose if the question assume that 0, 1, 2, 3, 4, 5, assume that we are having elements 10 and then 15, 8, 20, 21, 35. I came to know that there is one question, that is what is the time complexity for finding an element which is not largest, How to find an element which is not largest? Simple logic, just compare 0th index and first index element. Suppose if the name of the array is A, you just compare like this, A of 0 and A of 1. Suppose if A of 0 is greater than A of 1, then obviously A of 1 is the not largest element. Or else if this condition fail, I can say A of 0 is not largest element. So therefore the time complexity for finding an element which is not largest, obviously which is not largest means it takes only order of 1 or theta of 1 time. So I came to know this question, okay, and we will collect more number of questions and we come up with the exact solutions. And anyway, thanks for attending this session, and it one more time I am going to repeat, ACE Engineering Academy is conducting or offering coaching classes for GATE 2026 aspirants. The coaching pattern, it is online as well as offline mode is available, okay. So people who are appearing for GATE 2026, please enroll into ACE Engineering Academy. Our support is always with you, okay. I wish you all the best. Thanks for giving opportunity on behalf of ACE Engineering Academy. Thank you.